Hi friends, today we are going to discuss on the Posix system calls. This presentation is presented by Pallavi Jitendra Kumar Bhalela and Vaishnavi Subhash Kulkarni. So the first system call we are going to see is the get domain name. So this system call is used to retrieve the domain name from the user. So the syntax is as shown below. We have to pass the two parameters, that is the name and the length. In name it is the array, declared array, where we can get the name of the domain, and the length describes the length of the domain name. Next system call is the host name. The parameters are same as the domain name. Here we have to specify the name that specifies the name of the array in which we are retrieving the host name and the length of that host name. So both the two system calls are combined in the below program. In this we have used this standard header file such as the stdio.h standard library and the uni.std. It is used to manipulate the file descriptor. In the main program we have shown that we have declared one variable name as the host name and its size is there 1024, and similarly we have to retrieve the name we will use the command get host name, and in bracket we have declared the variable host name and its size, so it will print the host name from the user. Similarly we can print the domain name from the user. The next system call is the write system call. The write system call retrieves the number of bytes specified in the parameters from the buffer. So it is used to retrieve the last bytes, which the size of the bytes which we have specified here. Here the syntax is given in this integer d constant void pointer is used. This is the buffer, and this size tn byte shows how many bytes we have to retrieve from that user. So here is one example, basic example. The header file fc and tl is used. It is used to declare the standard constants and variable types. So in this we have take one buffer. In this we have written one message, that is a text record to be written, and in the main function we have retrieve from the buffer. This is the file descriptor and this is the buffer name. So we want to retrieve the last we want to retrieve the element stored in the buffer. So if if the size written is not equal to the size of the buffer, then the error message will be displayed that the elements cannot be retrieved from the buffer, and the file descriptor is closed and the exit is performed. Similarly the next command is the remove directory. It is used to remove a directory from the system. So the syntax is simple. We have to give a character, that is the name of the directory and the path where the directory is stored in the system. So this command removes the directory file whose name is given by the path. If it is removed successfully, then it will show the value 0, else it will show -1 value. So in the example we can see the standard header files are used. Below that the main program is there. In this we have declared one variable k, and we are removing the directory named as operating system. So if k is equal to 0, then we can print that the directory is removed, else then the directory is not removed. We can if we directly give the command on a command prompt, so then also it will remove the directory from the file. The next system call is fchown. It is used to change the owner ID or the group ID. So the syntax is as shown below. In this we have to pass the three parameters, that is the user ID, the name of the group ID. Syntax. In the syntax we can see there is a character variable, a pointer that shows the path of the directory path of the file which we want to change. So by using this we can change the user ID or the group ID. If this command is run successfully, it will return the 0 value, else it will return -1. The example is as given below. In this we have declared one array, and we have declared integer variables such as I, E and fd. So we are using a for loop to enter into that. In this we are using a file descriptor. It will open the file, and if the arguments are matched with the given variables, it will change the user ID and password, else it will show an error message. Then we have closed the file directly and return 0. Next is a fork system call. It is used to create a process. Fork system call creates a new process. The program is given below. The next system call is the get PID. Get PID is used to display the process ID. The syntax is basic. We is shown below as get PID opening closing bracket. So in the below example, the get PID and the fork system call is used. Here we have declared one variable I, and we have assigned the fork to that. So we have printed that the process ID will be print. So we can get the process ID by using the fork system call. Next is the make directory. Make directory is used to make a new directory file into the system, or a folder into the system. The syntax is as shown below. In this we have to pass the path where we have to create the new directory, and in which mode we have to create the directory, means read mode, write mode, or elsewhere. The program, the next system call is the change directory. It is used to change the working directory, means if you are working in one directory and we want to change from one directory to another directory, then we can use this change directory command. So in this the path is necessary. The path specifies from which directory we have to change the other directory. So it will show the 0 if it is done successfully, otherwise it will show -1. The example is given below. In this we have passed one argument and one array is declared. We have to pass two arguments, that is the source file and the destination file, so that the path can be changed. So if argument is equal to 2, then we can use the cd command, that is the change directory command. Otherwise, if it will show if we are passing only one argument, it will show an error message that the directory is not changed, that is it shown a -1, that is the error message will be displayed. Or else in the print statement the directory change message would be displayed. Next system call is the get cwd, that is used to display the current working directory. So the syntax is as below. We have to declare one buffer and the t size, that in which directory we are working. Buffer displays the path where we are store the directory and the size of the buffer. So in the below example we have explained the system call. Here we have make one directory name as os2, and if the directory is created successfully, it will display 0, otherwise it will display the -1. So in this we have to get the get cw. It is used to get the, so as in the print statement we have given the get cwd command. It is used to display the current working directory, and then we are changing the directory from root to the system call, and after changing it will print that the directory changed from root directory to the system call, that is the os2. In system call we are creating the new directory, that is the os2. Next is the rename. Rename is used to change the name of a file. The syntax is as below. This is the character from which from what, means we have to pass the two parameter. What is the old name of the directory and what is the new name we are going to assign it. So it causes the link name from and to be named as 2, means from what name we are giving means for what is our previous name and what is the new name we are assigning to the directory. The example is as shown below. In this we are renaming the old .txt directory to the new .txt directory. If it is not done successfully, then it will display the error message that error in renaming the directory, else it will rename the directory successfully.
So the next system call is the receive system call. For the receive system call is used to receive a message from a socket. Syntax for it is socket is used to receive a message from it. So in this integer yes is declared, character is used as a pointer, buffer is declared, and length is given, and flag is used. So receive system call is used to receive the message from a socket. It returns the number of bytes which are received, and if and -1 it occurs, then error is occurred. For the next system call is the send system call. In the send system call, the syntax is that first the size is given and void message is printed, length is declared, and the flags are given. So the send system call is used to transmit a message from one other socket. It returns the value, it returns number of bytes which are sent if it is successfully executed, and it returns -1 if an error is occurred. Mount system call is used to mount a file into the another file. So syntax for this is that header file is used as /include system. We can use the system or the mount.h. So in this character is used and the flag is declared and the type is given and the length of the data is given. So the description for it is that mount system call is used to mount the one file into the another file. Next system call is the open system call. The open system call is used for reading or writing into the file. So the header files used for this are system.h, stat.h and fcntl.h. It is used to manipulate the file descriptor. And this, in the open system call, the open function opens a file descriptor for the naming the file and says the file status flag according to the value of the flag. So example for this is first of all, file descriptor is given and file descriptor opens the file named as match.txt. So the next system call is the bind system call. Bind system call is used to bind a name to the socket. The syntax for it is given as system.socket is used in the header file, and the pointer and the name of the length is given. So here the socket name and the socket address is given for which file we want to bind it. Bind system call assigns a name to a unnamed socket. So means to give a name to the socket, mount system call, bind system call is used. So the next system call is the pipe system call. Pipe system call creates a descriptor pair for the interprocess communication. The syntax for is that header file is used at UNISTD, and in this file descriptor is used. File descriptor is used for the interprocess communication. So one program can communicate with the another program by the intercommunication. In this example, as given as, so in the example it is explained that first of all, file descriptor is given and buffer is declared. In this, pipe is used. Pipe is used to communicate one program with the another program. String length that the data is given. Then in the buffer 1024 bytes are taken. If it will take if it is declared, then it will give the buffer value, and if it is not executed, then it will give the error value, that is read. So the next system call is the link system call. It is used to create a link to the existing file. Syntax for this, it is used as the UNISTD. It is used to manipulate for the file descriptor. In this, it returns the value 0 if executed successfully, and it returns the value -1 if an error is occurred. So in the example, it is given as integer I is declared. Then it links the file text.txt with the another file. So for this, link system call is used. Unlinked system call. Unlinked system call is used to remove a directory entry. Syntax for this is that the path is specified in this. Unlinked system call removes the directory entry name referred to by the path. So in the example, it is given as, so the unlinked system call removes the directory entry name referred to by the path. In the example, it is explained that removing the temporary file, first unlink whatever the file name we have to give here, then it will give that print the removing the directory, it is removed. Then the next system call is the unmount system call. Unmount system call is used to unmount the file which is mounted in another file. So the unmount system call gives the file system object on the system. In the syntax, it is given as the data is taken and the flag is declared. The last system call in our document is the truncate system call. The truncate system call is used to truncate the file to of the specified length. In the syntax, it is given as the path is given as the pointer and the length is declared. Path specifies the file to be modified and the length specifies the offset length. So in the example, it is explained that first of all, integer j is declared. J is taken as whatever the route or whatever the path we want to truncate, it is taken as Then printf the file will be truncated, returns 0. Thank you.